As we know, SQL is a, or SQL is a structured query language, and the commands which are available in SQL or SQL is categorized into these four categories. One is data definition language, the second one is data manipulation language, third one is data control language, and TCL, which is transaction control language. Okay, so these are the four main categories in which all the SQL commands belong to. The first category is a data definition language, in which the commands which are used to create, alter, drop, rename, and truncate, these group of commands belong to data definition language. So under create, we can create a new database objects such as database or tables. DDL command also deals with altering these definitions of an existing object. It could be database or a table. So the commands, the other commands which we can use is to drop a database, to rename a database, and to truncate a table. So what is truncation of a table? So that means it is used to remove all rows from the table without logging individual row deletion. Okay, so what is data manipulation language? Data manipulation language is nothing but it is a set of commands which is used to retrieve, insert, update, remove, and manage the data. So DDL is nothing but a definition language wherein we define the objects, and DML deals with managing the data within these objects, such as insert, update, delete, and select. So these are the different commands which are used to retrieve or manage the data. So these are the different commands used to manage the data within the database. Okay, so select command is basically to retrieve one or more rows from a table. Insert is to insert one or more rows into a table or a view, and update is change an existing data in the table or view. That means insert will insert a new value, update will update the existing data. Okay, so delete removes the rows from the table or view. Okay, so we would be mostly concentrating on DML part in the later sessions. Of course, we will deal with data definition language because we need to create those objects before we start working on DML. Okay, so data control language is set of commands which are mainly used by administrators. So whenever we create a particular database, so who can create a particular database and who has access to query? So all these DDL, DML can be controlled by providing a grant to a particular user. So that is why this is generally done by administrator. So he or she can provide grant, and he or she can revoke the permissions. So whatever the permissions which we have, either to insert or update or delete or select, so he has various commands or various criteria for granting the access or revoking the access, both for DDL as well as DML. Okay, so TCL, transaction control language. So what does transaction control language do? So it allows the DML statements to be grouped into a logical transaction. So this is very important. It allows the DML statements. So DML statements are like select, insert, update, and delete. So they can be grouped into a logical transaction. Suppose say if you are inserting into multiple tables, say for example table 1 and table 2. So let me open up MS Paint here. Suppose say I have table 1 and table 2 here and table 3 here. Okay, and this is table 1 and this is table 2 and this is table 3. Okay, so whenever we insert a particular value into table 1, so that will in turn insert something into table 2 and that will in turn insert something into table 3. Okay, so now the table 1 we have inserted a particular row successfully. So we have inserted something successfully and it in turn added some values into table 2, and in table 3 for that particular information which is all related between table 1, table 2 and table 3, under table 3 it failed. Okay, so now what will happen to the data in table 1 and table 2? Since these items which we are trying to insert are all related items. Okay, so since it failed in table 3, if we don't have if we don't use the transaction, then what will happen is we will have redundant data in table 1 and table 2, and table 3 will not have a related data for this particular row which we try to insert. Okay, so in such cases what we do is we use transactions. What transaction will help us is, so if at any stage there is a failure for related items which are getting inserted into multiple tables, then if one of them fails, then it should roll back to its original state instead of having a redundant data. Let me repeat this. Okay, so it has tried to insert one record here. Okay, one and it is a related record, and here record 1 failed. Okay, so when this record 1 fails, then there's nothing gets inserted into this table 3. Okay, nothing gets inserted into table 3, but we still have a record in table 2 and table 1. Since they are since the data which we are inserting, they are all related items, and this becomes a redundant data now. Record 1 under table 1 still exists and under table 2 still exists, even though we don't have record for record 1 under table 3. So this is not the situation which we want to. So instead of inserting it separately, so what we do is we add all these commands into a group. That is nothing but the transaction control language. So what it does is it allows DML statements to be grouped into logical transaction. So whenever we insert into all 3 tables successfully a record, then only we consider that particular transaction is successful, else it is unsuccessful. So we can group them by using begin transaction. Under begin transaction, we will group all the DML statements, and once we are satisfied with the transaction, once it is successfully inserted into table 1, table 2, table 3, then we go ahead and commit the transaction. Else we will roll back the transaction. Once we commit, it will commit the records into all three tables. If we roll back, then it will take out all the data from all these tables. Once that particular transaction is failed, it rolls back to its original state. So that is how this transaction control language works. Okay, so we have seen DDL, DML, DCL, and TCL. So mainly we will be concentrating on DML in the upcoming sessions. Hello friends, welcome to another session of video tutorial on SQL. In today's session, we will go through SQL constraints. What are constraints? Constraints are nothing but a predefined set of rules and restrictions which are applied to a set of columns or a particular column. Constraints are needed to maintain the data integrity, accuracy, and reliability of the columns data. Since these constraints are applied to a particular column, so we want to ensure that the data which is entered into that particular column or set of columns follows some rules and restrictions, so that whenever we retrieve data, so we get a accurate data. There are few SQL constraints which are available. One is null or null. There are few constraints available: null, not null, unique, primary key, foreign key, check constraint, and default constraint. So these are the set of constraints which are available in SQL, which I'm going to go through. So what does null constraint do? So null constraint will what does null constraint do? Null constraint will allow you to add a null value to a particular column. So what does not null do? Not null will not allow you to add a null value to a particular column. Okay, so what is unique constraint? Unique constraint is the one which doesn't allow you to add duplicate values. And the next constraint is primary key. Primary key defines that a particular row is identified by a unique ID, which is primary key. So now you might ask, what is the difference between unique key and primary key? So unique key allows you to add null value, but primary key will not allow you to add null value. Unique key will allow you to add one null value. It can have one null value, but the primary key cannot be null. The next constraint is foreign key. Foreign key is the one which combines or links two tables together. So if you have table 1 and table 2, they are linked together based on the foreign key. Basically, the foreign key identifies the relationship between the two tables, like a parent and a child. So we will see an example of all of these, but let us move on to check constraint. Suppose say if you want to restrict the user by certain numbers, say for example age can be between 20 and 80, And if you want to restrict a particular age column to have only these values, then you can add a check constraint for that particular column. And the last one is a default constraint. A default constraint is used to provide a default value. For example, if you want to insert a date, which is today's date, whenever you insert a record into the table, then you can provide the default value for that is today's date. If you specify a particular date, then it will insert that particular date. Otherwise, it will insert today's date. So these are the different constraints available. We will try to create a new table and try to see each of these constraints. So we are going to create an employee table with these columns: ID, name, address, grade, department, salary, and date of joining. And while creating, we will see how to add these constraints to some of these columns. Okay, so let us go to SQL Server Management Studio, and I select the database. I'm going to create a new database here, and I'm going to call it as SQL demo. Okay, so it has created this SQL demo database. Okay, and under SQL demo, I go to table, right click, and then click on table. So this is the table which I'm going to create. The name of the table will be employee. And now I start specifying the column names. The column names which we were thinking of were ID, and the data type here is integer, and for the time being I'll leave it as it is, but I'll explain it later. We'll try to create all the columns. Then the name, and name will have varchar, varchar, and the name can be of 100 characters max. Okay, and address, again varchar, and the address can be up to 1000 characters. And the grade, which grade that employee is allotted with, again this is going to have varchar of 50. 50 is enough for a particular grade. And department, and again the department name can be again varchar of 50. And salary will be, again for simplicity I'll make it as integer. And date of joining, DOJ, and this will be a date column. Okay, so we have created all the columns now. So we will see the first constraint now. So we will see the first constraint, which is not null or null. Okay, the first constraint is, okay, here by default all these columns are added with allow nulls constraint, that is null constraint. That means all these columns can have null values, but it doesn't make sense to have a null value for an ID. So we will see each column. So ID cannot be null, and the name cannot also be null. Address, if the person or if an employee has moved from one state to another state, then he might not have a permanent address, so address can be empty at this point of time. So I will say allow nulls. So that means I'm applying null constraint to this particular column and not null to ID and name for now. Okay, every employee will have a grade and every employee will be allocated with a department. Every employee will be paid with some salary and he has a specific date of joining. So that means we have added not null constraint on all these columns and null constraint on address column. So we covered null and not null. So now let us see how to add unique constraint. So let me save this table first. Okay. Now the name can be same, right? The name can be same, but the ID cannot be same. So what I will do is ID and name. These are the combinations of columns. I'm going to create it as unique constraint. That means an employee can only have ID and name unique across the organization. There cannot be any duplicates. So I selected these two columns and go to index and keys, click on add, and here is unique, yes, and type will be unique key. And the columns which I need to select here is ID and name, because these are the two columns which is unique across the organization. Okay, and I'm going to call this identity as ID name unique. Okay, and click on close. So we have added ID and name as a unique constraint. Okay, now next one is primary key. So the primary key for this particular table will be ID. So I need to make this ID as primary key so that there won't be any duplicates, because two employees cannot have the same ID number. Okay, so to make it as primary key, I right click on this and set primary key. Okay, so there's a key appearing here. That means this particular table has this ID as primary key. Okay, so foreign key we will deal in the next session. Whenever we create two or more tables, and whenever we create two or more tables with the relationship between those three tables. So I can also add a check constraint here. The minimum salary is, say for example, $500, right? And I can add a constraint here saying that the salary cannot be less than $500. Okay, for that I need to right click again, and there is a check constraint. Select check constraints and click on add, and the expression which I'm going to give here is, okay, so which column? The salary column should be greater than $500. So this is the syntax which says the salary must be greater than $500. Otherwise, it won't allow you to insert a record. And the name of this is, I'm going to check constraint salary greater than 500. Okay, and this is applicable for existing data, and when this is enforced during insert and updates, and this is enforced for replication also. Click on close. Okay, so we have added this check constraint also. So what we will do is we will add a default constraint. Suppose say if I don't provide the date of joining, then it should take today's date as date of joining. Okay, so how do I ensure that? So I select the particular column which I want to make, which I want to have a default value, and under this column properties I have a default value or binding. So here for date there is a built-in function called getDate. So this is the function which fetches today's date and provides it if there is no value for this particular column. So that means it will add today's date into that particular column. Okay, so far we have added null constraint, not null constraint, unique, primary key, check constraint, and default constraint. Okay, so now we save this, and now we will add data to this particular table. Okay, for that I'm going to click on new query. Okay, so now select star from employee. Okay, so you need to make sure that you are referencing to a particular database or the specific database which you want to query on. So in my case it is SQL demo. So let me query this, execute, and there is no data here. Okay, so now I'll start adding the data into this particular table. Insert into the table name is employee, which has columns ID, name, address, ID, name, address, grade, department, salary, grade, department, salary, comma, grade, department, salary, and date of joining. And the values which I'm going to add is, for example, 1 for ID, name will be Jack in single quotes, Jack, and address is, let's say, New York, and his grade is Jack, New York, and the grade is, say, software developer 1. That's he's joined as a new employee as software developer 1, grade 1, and department is, say, for example, big data. His salary is, say, $5,000, and date of joining is, again, today's date, which is, let's say he joined on 2018 September month and 15th date. Okay, let me minimize this so that we see the entire query here. Okay, so these are the values which I'm trying to insert into this particular table. Okay, let me run this query, execute. It says one row affected, and let me select the query again. Okay, you can see that Jack has been added. Okay, now we will see one by one, not null constraint, right? Okay, so everything else remains the same. So what I'm going to do is I'm going to copy this here and then paste it here. What I'm going to do here is, since name is not null, I will try to add a null value into this name column. So for that, I need to change this to 2 and then add null value. Okay, make sure that it is not this. So this is still a value with empty string in it. Okay, and it's not a null value. Okay, if you specify null, then it's a null value. Okay, let us try to insert this into the table. Okay, so we got cannot insert the value null into column name table. Column does not allow nulls. So that means it is verifying that constraint that this value cannot be null. Okay, so the next one is and then null. Okay, so which column did we define as null? So address. Okay, so instead of having null here, I'm going to add a value here. Name can be Christine and let's say dollars and C2 again big data and salary is 10,000 US dollars. Okay, and the joining date is 18 to 17. Okay, so I have changed all the values. So here we are trying to check for this null constraint. So address is Dallas, right? So I put in Dallas earlier. So I'm going to remove that. And I'm going to add null here. Okay, remember that null is different to empty string. Empty string is still a value, null is not a value. Okay, so I'm going to execute this one. Okay, you can see that it has added one row even though we provided null value because we are allowing address to have null value. Okay, so if I select, I should have 2 entries. Okay, you can see the address is null here. Okay, so we have seen not null and null. Okay, the next one which we will see is the primary key. Okay, the primary key is unique across the entire table. So the primary key is unique across the table, and we added ID as a primary key. Okay, so here that means we cannot have okay, we have added ID as a primary key earlier, so that means ID cannot have duplicate values. So let us try to insert this, the first SQL statement with the values. So one already exists, so I will say Jill and this I can say Texas and SD2 and this is IT infrastructure and okay, the date will be say for example 12. Okay, so here ID already exists, ID1 already exists. So if I try to execute this, then it should give me a violation of primary key constraints. That means I cannot add the same value for that ID, even though everything else, all the other columns are different. Because since this ID already exists, it doesn't allow me to have another value with the same ID. So that means it is checking for this primary key constraint. Okay, so let us check at unique constraint. Okay, since we added ID and name as unique constraint, since ID also has a primary key constraint, what I'm going to do is I'm going to remove this primary key constraint for the time being, just to check for this particular unique constraint, because if I add another value here with this ID constraint, then it will check for primary key, not for the unique constraint. So that is why I have removed primary key here, and I'm going to save this. Okay, and I'm going to copy this, the second statement. Okay, so unique constraint in our case is ID and the name. Okay, and I'm going to change everything else here. Okay, so here SD3 and big data platform team, and here I'm going to say it as 6,000, and I've changed the so everything else is changed except ID and name is the unique constraint, and it cannot have duplicate values. Okay, so 2 and Christine is already added with the different values for all the other columns, and I'm trying to add the same with different values for all other columns except these 2 columns which already exist. Okay, let me execute this. Okay, okay, as you can see, it is a violation of unique key constraint. The name of the constraint is ID name unique. Cannot insert duplicate key in object employee. The duplicate key value is 2 and Christine. So if I change the value to 3 and execute this, it should allow me to add a new value. Okay, so this is how unique key constraint works. Okay, let me add the primary key again back. So save this. Now we have seen unique, not null, null, primary key, and we will check for check constraint. Okay, so we'll add another one here. Check constraint. The check constraint says the salary has to be greater than 500. So I will add another employee. Okay. So instead of providing all the column names, so I'll provide just the values here. Values. And I'm adding a fourth entry, and the name can be Joe, and Joe is from Washington, and he's team leader 1. Grade is team leader 1, and he belongs to, let's say, finance team, and his salary is $300. And he joined 2016 03 and 15. Okay. So whenever I remove these column names, I must have all the column values here. So I have all the column values here. 4 represents ID, and Joe represents name, Washington represents address, TL1 represents grade, finance represents department, and salary represents 300 represents salary, and this is the date of joining. Okay, so let us execute this. Okay, so here you can see the insert statement conflicted with the check constraint CC salary greater than 500. The conflict occurred in the database SQL demo table DB employee column salary. So that means the salary constraint is checked here. It won't allow us to insert any new row with salary less than 500. So I will make it as 3000 and insert it. Okay, one row affected. So let us go back and select all the employees. So Joe is inserted and his salary is 3000. Okay, so that's our check constraint. Now let us look at the default constraint. Okay, what does default constraint say? Default constraint says if I don't provide any value, which column did we add default constraint to? Date of joining. So what this does is, if I don't provide any value to this date of joining, then it will take today's date. Okay, so here I will copy this and paste it here, and I won't provide any value here. So I will completely remove this, and I will change the ID and Maria, and she's from Brazil, and she is team lead grade 2, and she is in procurement department, and her salary is, say, 5000. Okay, now I have not provided the column value for date of joining, so it should pick up a current date. So let me insert this. Okay, as I said earlier, whenever we provide only values, then we should provide the values for all the columns. So since I'm missing date of joining, so I need to provide the column names as well. Okay. I'm going to take out the date of joining. So let me execute this. Okay, so one row affected. So now let us go back and see whether Maria has been added to our table or not. Okay, so Maria is added and the default date is being added. Even though we didn't provide any date value here, but it added the current date as date of joining. Okay, so we have seen all of these constraints except foreign key, which we will deal with in the next session. Okay, so that's all about SQL constraints. In this session, we will take a look at foreign key constraint. We will continue on where we left off with the constraints. The only constraint which was left out was foreign key, since we didn't have multiple tables. So we just created one table. And so now we are going to create another table and create a relationship between these two tables by using a foreign key constraint. So foreign key constraint is used for referential integrity. So that means while we are inserting the data into one table, it will always check for the integrity of that particular data in the other table also. So if you want to have that constraint, we need to create a foreign key. So how is it different from primary key? A primary key is unique and you can have only one primary key per table. However, you can have multiple foreign key for a particular table, and primary key will not allow null values, but foreign key will allow null value also. Okay, so having said that, so we will try to create another table. In our employee table, we have something called department. So we added, big data platform, finance, and procurement. So instead of adding the department name all the time, so what we can do is we can create another table called department, and we can add the foreign key for that particular department so that employee and department tables are related. So what we can do is after adding employee, so we are going to create department table. So under department we will have ID again and name of the department. ID again, we are going to create it as a primary key, because only the primary key from the other table can be a foreign key for the other table. So in my case, the department ID, which is a primary key in department table, is a foreign key for employee table, and the name is the name of the department here. So what I'm going to do is, instead of department, I'm going to modify this particular column from department to department ID. Since the two tables will be related now, so instead of putting the department, so I'm going to put department ID or department ID. So first thing is, I will create the department table. So for that, I will go to SQL demo and go to tables, create a new table, and here I will create ID, which is the first column. Again, it is an integer, and the second column is name of the department. Okay, and again varchar of let's say 100. Okay, ID column will be our primary key. I'm going to set this as a primary key, and whenever I set this as a primary key, it won't allow null. Okay, so the name also I'm not going to allow null here, and this table I'm going to call it as department table. Okay, I'm going to save this. Now I'm going to go back to the first table definition, and instead of department, so I need to call it as department ID, and this will be an integer now. Okay, so let me save this. After changing the data type, it says unable to modify table, conversion failed when converting the varchar value to big data type to int. So that means earlier it was varchar and now it's going to be an integer value. So for that I need to remove all the records inside the employee table. So for that I'm going to use delete from employee table. Okay, and I'm going to run this execute query, and 5 rows are deleted. Okay, and then I'm going to go back to employee table and then save this. Since there is no data now, so it should successfully change it to from varchar data type to integer data type. So select star from employee and select star from department. Okay, so let us see. Let's see, select star from department, sorry, employee. There's no values. Select from department, no values. So what we will do is, first we will add the departments. So here I'm going to add values to department table. So again, insert into department values 1 big data, okay, and finance. So we had big data and big data platform and finance department and procurement department. So this is what we had, the different departments, procurement departments. So what I will do is I will go and insert these, okay, one by one into, sorry, I need to change the values here. ID cannot be, since ID is a primary key. So let me change execute and execute. So if I go to select star from department, I should have 4 different departments. Okay, so now I have 4 different values. So still my employee is empty. So before we go ahead and add the data into employee, what we will do is we will create foreign key constraint. So for that, what we will do is we will go to employee table and select the department ID go to relationship, click on add. Under tables and column specification, you click on this three dot. So let us call this as EFK, which is foreign key, employee to department. Okay, so the primary key table is, in our case, the primary key table is the department table. Okay, and the foreign key table is employee table. Okay, so let us remove this. Okay, from the department table, which is the primary key? ID is the primary key. ID is the primary key which we want to relate to the table employee, and what is the column which we want to relate it to? It's the department ID. So that means the primary key table is department. So this is the relationship which we want to build from department ID to department ID in employee table. Okay, click on OK and then close. So now we have built a relationship between these two tables. We need to save this, so let us save this, and it says the following tables will be saved into your database. Do you want to continue? Yes. Okay, so now that constraint is saved. Okay, so after saving, what we will do is we will try to insert few rows into employee table. So what I will do is I will take out the first statement which we tried to insert earlier, and then add it here. So this is from the last session. Okay, so employee ID, name, address, department. So instead of department, it's going to be department ID now, and salary. The values are okay, so the values are 1 Jack, New York, SD1 instead of big data. So we know that big data is big data is 1 here. So instead of providing this, so I'll provide 1, which is an existing data in the department table, and everything else remains same. Let me execute this and see. Okay, so right now one row affected, and then let's go back and see the employee table. So I have one row with all the values in it. So the department ID, instead of big data, it says 1, which is referencing to big data and department column. Okay, so now where is the referential integrity here? So there's nothing which is stopping us from inserting. Okay, so to check the referential integrity between these two tables, whatever the constraint which we have added is in place or not. So what we need to do is, since we have only 4 values here, so if I try to insert another row into employee table, okay, so this time I'm trying to insert Jill, and he's from California, and he's SD2, and he's from a procurement department. Okay, so procurement department, and he's earning $5,500, and then he's joined on some date. Okay, so he's from procurement department. So right now the procurement department is not inside the department, so we haven't added that particular value. Since we have a primary key on employee, so let me change the value of employee ID. Okay, so let me try to insert this. Okay, the insert statement conflicted with the foreign key constraint AFK employee department. The conflict occurred in the database SQL demo table department column ID. So that means this value, whatever we are providing in department ID, doesn't exist in the department table. So it is referencing, that means it is checking the department table before inserting the value into employee table. If I insert into department values 5 comma and infrastructure, okay, so and let me execute this, and now the fifth value also exists in the department. Let's go back and select this. Now there is a infrastructure department. Since Jill belongs to infrastructure department and there is a value now the check constraint passes and then it should insert a value into employee table. If I execute the same statement again, okay, one row affected. Okay, now if I go back to employee, I have Jack and Jill, and Jack belongs to big data and infrastructure department. Okay, so this is about foreign key constraint.
In this session, we will go through the data types which are available in SQL. There are basically the data types in SQL can be grouped into 4 different groups. One is numeric data types, date time data type, string data type, and other data type. So under numeric data type, it can be classified into integer and real numbers. Integers, as you know, that it can be integers can be like int, big int, small int, and tiny int. So they are all differentiated by the memory which is getting allocated. So for int, 4 bytes, big int, 8 bytes, small int is allocated with 2 bytes, and tiny int 1 byte. So there are several others like money, small money, numeric. There are other numeric types which are real numbers, and the data type can be decimal, float, real. For integers, it is based on the number of bits or bytes getting allocated. But in terms of real numbers or floating point numbers, it is based on the precision. So after decimal point, how much precision we want to have, like 7 digits, 15 digits. So these are differentiated by these floating point numeric numbers or numeric data types. Okay, so there is another one called data type, which is used to store date and time information. So there are several of them, such as date time, small date time, date time offset, date time to, and time. So this is for further reading. You can go into any other tutorial, or you can read up the Microsoft documentation for various data types. Okay, but numeric data stores the numerical values. Some of them may be floating point values, some of them are integer values. Okay, and date time stores date or time or date time together. So to store those type of values, we use date time data type. And the third one is string data type. In string data type, we store a fixed length or variable length strings. So char x means char, varchar, and text is used as a string data type. And char x means so x space is allocated to store a particular character. So if suppose say if you allocated 10 as value of x, so that means all 10 bytes are padded. Okay, so it will store the value, and the remaining space which is allocated is padded. Okay, so suppose say you have allocated, suppose say x value is 10 and you are storing only one value there, so the rest of the space which is allocated will be padded. Okay, so that means whenever you define x value, so it is allocating that much value or that much space or that much memory upfront, and whatever is not used, it is being padded. Okay, and in varchar x, so there is no padding allowed, so that is the difference between char and varchar. Under text, you can store long text information such as paragraphs. That is, you can store long text into this particular data type. Suppose if you have a big story and if you want to store paragraphs into a particular column, then you can make that particular column as a text data type and store the value. Apart from these, the other data types are blob, which is nothing but binary large object which is used to store pictures and videos. And there's a binary data type which is also used to store the binary string format. So it will store everything in a binary format. Binary means zeros and ones. Okay, so there is something called image also, which can be used to store image other than blob. These are the different data types available in SQL. While deciding the tables which you create, so you can decide which type of data it is going to store, and based on that you can define these data types. In the previous sessions, we have seen how to use constraints, and in the last session, we have seen how to use foreign key constraint. In this session, we will go through logical operators. These are operators which we can use. There are arithmetic operator, logical operators. Like any language, we can use these operators to operate on the operands. So some of these are logical operators, comparison operators, and comparison keyword. So there is arithmetic operator as well, which includes addition, subtraction, multiplication, division, and modulus operator. Let us look at some of the arithmetic operators now. Okay, for example, select 10 plus 12 as addition. Okay, so here addition is an alias for the column name. So here addition is an alias for this particular column name, which is addition of two numbers, and here we have used this arithmetic operator. Okay, let me execute, and you can see the column name is addition, and so it has added these two values. And the same way we can also have select, say for example 20 minus 4 as subtraction. Okay, and execute this. Okay. The same way we can have select 20 multiplied by 4 as multiplication and select 20 divided by 4 as division and select, so for example, 32 divided by 3, sorry, modulo operator, 32 percentile 3 as 1. So modulo basically gives you the remainder. So let us see multiplication. So 20 multiplied by 4 is 80, and division, so which is 5, which is correct, and this should give us the remainder. The remainder is 2, 3 times 30, and the remainder is 2. Okay, so this is how we can use arithmetic operators. Okay, let us look at logical operators. Logical operators which we are going to look at are AND, OR, and NOT. So AND operator is the one wherein if both conditions are true, then the output of this AND operation will be true. So in case of OR operator, if one of them is true, then the output of that particular operation between those two will become true. So NOT will negate whatever, either true or false. Okay, so let us look at these logical operators now. So for this, I'm going to introduce a new keyword, which is where. Okay, and where will be followed by other conditions, and inside those conditions we are going to use AND, OR, and NOT. Okay, let me open up another query window here. Okay, so let us select star from employee table. Okay, and execute. So here we have department. Obviously we have only 2 entries in here. We can use the first AND operator. Okay, so select star from employee where, okay, so this is the clause, and the condition is where salary is equal to 5,000 and department ID is equal to 5. Okay, so here what I'm saying is, so select everything from employee table where salary is equal to 5,000 and department ID is 5. Okay, so by looking at the results from previous select, what we can say is there is one record with department ID 5, and there is no record which contains the salary with the department as 5. We shouldn't be getting any results here. Okay, so now let us go back to this and execute. So now what I will do is I will change the department to 1 here. So that means salary is equal to 5,000 and department is also 1. So both conditions are satisfied here. So it will return me the name Jack. One record which contains all the information. So only when both conditions are true, and then it is going to give us the result, else it won't. Okay, the next thing is OR operator. So here, OR operator. So I'll copy this and then paste it here. Paste it here. And now what I'm going to do is OR department ID is equal to 5. Okay, so I went back to the original one. Now in this case, if I added AND here, so it didn't yield any result. So now what will happen? Let's execute this and see. Okay. Now I got both the results here. So in this case, condition 1 says salary is equal to 5,000. Okay, so that is the first record which says okay, salary is equal to 5,000. But in the second result, the salary is 5,500. Okay, so it didn't satisfy this criteria. That is the first condition. But if you look at the second record, it satisfied the department ID condition, which is 5. So that is why we are seeing both records. So let us say if I add department 3, which doesn't exist, then the result is only 1, which is this particular condition is satisfied. Whatever the condition, so this will display all the records which satisfies this particular condition. So here this condition is not satisfied, so we don't have any records here. Okay. Now let us see not condition. Okay, so here okay, instead of OR, what I'm going to do is I'm going to use not keyword will take only one condition. Okay, so earlier and OR would take two different conditions, but not will take only one condition. So what this particular select says is select everything from employee where salary is not 5,000. Okay, let us execute. Okay, I should be getting only the salary which is not equal to 5,000. Okay, so if I say 500 instead of 5,000, if I say 500, then I should be getting both of them, because both of them are not equal to 500. Or for example, for that matter, 245, which is not the same. So I should be getting the same result. Okay, so that is about and, or, and not. Okay, so you can also use comparison operators. So one comparison operator we have already used in this, which is salary equals to and department ID equals to. So we have already used equals to, and we can also use not equals. So I'm going to copy that and paste it here, and instead of not, what I'm going to do is I'm going to use not equals to 245. So that means it should print me, or it should give the output of both records, which is not equal to 245. The same way, so this is again not equals to. Instead of using not equals to, we can also use less than and greater than together, and that should yield the same result. Okay, the only difference between these two are one is ISO standard and one is not. Not equal to is not ISO standard, and this is ISO standard. Okay, the same way we can also use less than, greater than or equal to, less than or equal to, and you can try out all these. If you have any comments or issues, so you can always comment in the comment section. Okay, the next one which I'm going to use is comparison keyword. These are keywords, these are not operators, these are keywords which can be used inside the query. Okay, so let us look at like first. Okay, I'm going to use the employee table again. Okay, copy and paste it here. Select star from employee. Again, these are used with where clause, where, okay, and the condition. And inside the condition, we can use these comparison keywords. Where name like okay, and then what we can have is J percentile and inside single quotes. Okay, so if I run this, what will happen here is select everything from employee where the name is like, and it starts with J and ends with set of characters. Okay, so when I execute this, I get both records. So if I change this back to J starting with JA, then I should be getting only one record, which is Jack. Okay, and it is not necessary that you use this operator only after this, but we can also use %J and percentage, which will also give you the two records. Okay, so there is nothing common in between here. Okay, what I will do is I will take address instead. The two addresses are New York and California, and we have O, which is common. So what I will do is % O and %R. So let's execute this. So it should print both. So both has got R, which is inside York it has OR, and inside California it has got OR. So it should again print both. If I change ORK, it should print me only one, which is New York. So you can add percentile anywhere, either at the beginning or at the end. So that will fetch the record matching whatever is between these percentile symbols. Okay, so that is how we can use like. And we can also use and or in conjunction with these other keywords, or say for example name like %J, and inside single quotes. Okay, so let us execute this. So you should see both records. Earlier we were seeing only one record. Since this condition is also true, and in here this is the first condition and this is the second condition. So it satisfied both conditions, so we got both the results. So let us look at in keyword now. For that, what we will do is from department. So we will fetch everything from department first. Okay, we'll fetch everything from department first. And here, if you want to select all those IDs where the name is either big data or finance. So in this case, what we can do is select star from department where name in big data, which is the first one, and finance. So fetch everything. So what this statement says is fetch everything from department where the name matches either big data or finance department. This is quite similar to OR. For example, select star from the department where name equals to big data or name equals to match. So this will also yield the same result. This will also yield the same result. Okay, so if you have multiple conditions, so instead of adding OR here, you can add them by using in keyword. Okay, and here between. Here what I want to do is I want to print all the records whose salary is between 2000 and 6000. So select star from employee and where salary between 2000 and 5000 or 6000. So 6000. If you want to get all the records between two conditions, then we can get by using between. So in this case, I got all the records from employee table where the salary is between 2000 and 5000. So for example, I can add it as 5500 and 6000. So I should be getting only one record, which is Jill. Okay, so he is the only person who is earning salary 5500. Okay, so this is how we can use between keyword. And we can also use this between keyword for finding out all the employees who have joined between year 1 and year 2, and you can specify the date, right? The same way what we have used here. Okay. The next one is null. We don't think we have any record which is null. If you remember, address can be null for this particular table. So what I will do is I will add a new employee. So basically I'll go back to this employee. So copy this. Okay, let me insert one more record here. Okay, let me insert one more record here. So I have copied the SQL statement from the previous session where we inserted a record to employee table. So in here, I'm going to change the ID name. ID name has to be unique. So we already have 2 IDs, and then let's say she doesn't have any address as of now. Okay, remember now single quotes is a blank value and it is not a null, so we need to change it back to null. Since this particular column takes null value, and st3, and she belongs to department 4, and her salary is say 6,500 and 18. Okay, so let us insert this. Okay, execute, and let's go back to employee table. Now we have 3 records, and you can see under address column we have 1 null value. Okay, so now let us look at our null keyword. Okay, so which is the last one here, comparison keyword. So what I want to do is I want to see all the records who doesn't have address. Okay, all the employees who doesn't have address, where address is null. Okay, select star from employee where address is null. Okay, execute. So now you can see Tara doesn't have address, which is null. Okay, so it's not together, it's is null. Okay, and there is something called is not null as well. Okay, so what this will do is this will do exactly opposite of what it was before. So instead of displaying Tara, so it will display all the records which are not null. Okay, Jack and Jill. So instead of adding a not is not here, so we can also use the not logical operator here. Okay, let's say not address is null, which will also give the same result as is not null. Okay, so these are some of the operators which we can use along with where clause. In the last session, we have seen how to use different types of operators. In this session, we will see grouping the results based on some of the functions which are available, such as count, max, min, average, and sum. So these are the functions which can group the results. And also, we can use distinct keyword, which is again used with the group, so that we can get the distinct values whenever we group them, whenever we group the results. Okay, so we will take a look at group by function as well. So group by function will group a particular result set based on the column specified after group by keyword. And we will also take a look at ordering the result set based on the column values by using order by keyword, either in ascending or descending order. Okay, so what I have done here is I have added few more rows into the employee table. Okay, earlier we had only 3, so I have added about 10 and with the different salaries, different date of join, grade, and department, and different address as well. Okay, so let us first start with the grouping functions such as count, max, min, average, and sum. So let me open up a new query here. So select count staff on employee. Okay, so let me execute this. So what it says is count all the roles. So what this says is count all the rows from employee table. So there are about 10 rows. So we can also specify the condition here by using where clause, where suppose I want to see how many of the employees are in grade SD1. Okay, so where grade is equal to SD1. Okay, so there are two of them with grade SD1. That is Jack and Anne. Okay, so we can make use of equals to, greater than, all those operators which we talked about, less than or greater than, if you want to select based on the salary. Okay, so what we have done here is we have used the grouping functions along with the different types of operators. These are conditional operators, right? Okay. The second one is we will take a look at max. Okay. Okay, select max of. So what I want to do is I want to get the maximum salary row from this particular employee table. Max of salary from employee table. Okay, so the maximum salary is 10,500. So if I want to get the name of the person as well as the salary, so select, and you can specify the column name, which is name and address, for example. So name, comma, address, comma, max salary. Okay. Okay, so we got this particular error. So that is column employee name is invalid in select list because it is not contained in either an aggregated function or group by clause. So this is what we are going to look at next after this. So whenever you specify multiple columns, then you need to group them by particular columns, so which we will take a look later. Okay, so for now I'm going to go back to this aggregate functions. Suppose I want to select the min value here. Select min salary from employee. Okay, so the minimum salary is 3,500. So 3,500 is the salary for Lucy as well as Anne, and here we are displaying only one particular value, which is min of salary. So how to display these two names, so we will take a look next whenever we deal with group by. Okay, the next one is average. Okay, select average salary from employee. Okay, the average salary is 5,475, which is sum of all these divided by 10. Okay, the next one is we will take a look at sum. Okay, select sum of salary from employee. Okay, so if you look at the sum of the salary, it is 54,750. So if you look at the average salary, 5475, which is sum divided by total number of records, which is 10. But is this correct value, the average salary? Because the salary here is repeated. For example, 3,500 is also repeated, and 5,500 is also repeated, and 6,500 is also repeated. So is this the actual average salary? No. So in that case, what we can do is I can take this average salary and I'm going to add distinct here. Okay, distinct is another keyword wherein it will fetch the unique records. So in this case 5,000 is repeated, so we will get only one 5,000, and for 3,500 there are two records, so it will take only one, and by doing that it will fetch the average. Okay, so let us look at this average now. Okay, the average is now 5,617. So if I look at this average, it was 5,475. Okay, so let me do this. Yes. And execute only these two. Okay, the first one is 5,475, the second one is 5,607. So is this the average? No. Since there are multiple rows with the same salary, we will get a different value when we average it out. So this should be our actual average. So that is where the distinct will come into picture. And distinct will give only the distinct values and then takes out those values and average is set out. And this is our average salary of the employees. Okay, so now we will take a look at group by functions. Earlier we were trying to add the name, and for example here, earlier we were trying to add name and address, right? So we got some error which says employee name is invalid in the select list because it is not contained in either an aggregated function or group by clause. So here we want to group them, group by, and we can specify columns here. Group by name and address. Group by name and address. Select this and execute now. Now you can see the name and the address and the maximum salary. Okay, group them by name and address. So if you look at this result, we are grouping them by name and address. So no name is similar. Okay, they are all different. But if you look at address, there is California which is repeated. If I want to get the maximum salary based on these groups, okay, for example, there is California which is repeated. So if I want to get based on the address, then the California should give me only 5,500. But since all others are unique, then it should have all the values. So if I want to get that, I have to remove this and then remove this, because that is not part of the aggregated function now. Now if I run this by removing name, now we had 10 records, so now we have only 9 records. Now if I look at California has got only 1 record, and the maximum salary there is 5,500. So earlier we had one with 3,500 and the other one is 5,500. Now it has aggregated based on this particular address. So that means it has grouped them and aggregated the salary. Okay. Suppose if I want to aggregate by name as well as address, so what I have to do is I have to add another row in here. I have to add another row. So let me see. Okay, I have Lucy from Texas. I will add another employee called Lucy. For that I will copy the query. Yeah. So here what I will do is I will add another employee with the same name, for example Lucy, and she is from Idaho, and SD2 as well as 1 and 4.750 and 10. Okay, I have inserted one more row. Now we have 11 rows. Now Lucy is also. So there are duplicate names with Lucy here, and we can also use them in our order by. So now if I look at, select name and address and group them by name and address, I should get, if you look at this result now, what happened here is, since we are grouping them by name and address, the name and address is not common for Lucy, even though the name is same, but they belong to different address. One is Idaho, the other one is Texas. Let me add another one. In this case I will add Jack. Okay, so I will add Jack, and he's also from New York. SD3, and he belongs to department 2, and so that's 5750 2019. Okay, So let me add this. Now if I go back and rerun this, I still get 11 records. Now we have two persons with the same name and address. So now they are grouped. So it is very important whenever we use aggregate function, we make sure that we group them by whatever the column which we need to fetch the correct results. So now we'll see order by. So select start from employee. Okay. So if you look at this, by default it orders them by ID. Suppose if I want to order them by name. Okay, so then order by name. Okay, now if I look at this, execute. Now we see that it is ordered by name. So we can add multiple columns here and they will order them based on whatever the columns you have specified after order by. Okay, if I execute this, okay, if you look at Lucy, since the first order is by name, there are two persons whose name is Lucy, and then it orders by address. So if you look at address, then this comes first with I and T next. Okay, so by default it is ascending. So either you can specify ascending here. If you don't specify, it is ascending. So there is no change here, but you can also specify descending by providing DESC at the end. Okay, now if you look at this, Lucy from Texas is in the beginning and Lucy from Idaho is next. Okay, so you can order them by ascending or descending. Okay, hope this is clear. If you have any queries, you can always post a comment and I'll get back to you. In the last session, we have seen how to make use of group by and order by, and also some of the aggregate functions. Okay, so there are several other functions, built-in functions available. So you can go to this docs.microsoft.com, and this is the link wherein it provides all the database functions and their categories as well here. There are a lot of categories here. Some of them may be useful in your day-to-day life, like string functions, for example. Under string functions, you can make use of trim, left trim, and right trim. So what trim does is trim will take out all the blank spaces from the beginning and the end of the string, and L trim will do from the left side, and R trim will do from the right side, but trim will do from both ends. Okay, and you can make use of substring as well. So if you want to get a substring called York from New York, so you can do that by using substring. And also there is upper and lower, so you can convert a particular string to upper and lower case. And also you can use string split, so you can split the string based on a particular delimiter. Okay, so let us look at one or two here and to see how that works. So I have here something called a replace. Okay, so what I'm doing here is I'm using a replace built-in function. So what this does is I have somebody called Alex in my employee table. I want to replace EX with AN. So the name of Alex will become Alan now. This is how we can make use of that. Select replace name. This is the name of the column. What you want to replace, that is EX, and what you want to be replaced with. So if I run this, then instead of Alex, I should get Alan. So this is how replace works. So I have another one. Okay, so Jack, Jill. So all of them will become uppercase. Another one here. Suppose I want to select all the employee name and their joined month. So if I execute this, okay, Jack joined on the 9th month, which is September, and Jill October, Tara October. So this will extract the month from date of joining and it will print those in my result set. Okay, you can refer to this and you can try out some of them. I'll put this link in the description and you can take a look at some of these categories and try out the way I did it here.